Okay, hello everyone, and so welcome back again. After a very after a very long time, so we didn't conduct any event from Innovation Tech Community. So once again, a very you know warm welcome to the Innovation Tech Community virtual world. So here I am Pratap Reddy, so Microsoft AMVP, so and the co-founder of this Innovation Tech Community. And so we usually conduct this type of virtual events. So if you are interested, if you want to learn something in a world, data world, so please follow Innovation Tech Community. So we usually conduct virtual sessions and in-person events and throughout the world. And yeah, so these are some of the things. And moreover, and I would like to tell one more thing. So the call for this is I mean this is a weekly series for next whole year. So if you are interested to share your insights in a world and data world, please submit your proposal in the call for speaker. So that would be really great. So if you are really looking for tech world exposure and all, so that is one of the thing. And one more thing, this session is mainly we are focusing on AI Foundry and move over what we can call it as so rack solutions in Azure as well. So I would like to tell you so how what is the importance of rack. So why we need rack especially, and one more thing, why we need so enterprise level. So most of the companies why they're actually looking for rack solutions for their business requirements and all. Okay, so meanwhile, I would like to share my screen so that it would be really good for us to communicate something about rack solutions and all. Okay, let me share my screen. So before that, and meanwhile, so yeah, so where we were chatting, so please reach out to me and please feel free to text me. Drop your queries regarding whatever the queries you have, and okay, so that it would be nice. We can communicate and what we are learning today and what we need to learn. So, and one more thing I just wanted to before I'm sharing screen, like, so this is a weekly series every Saturday. Actually, I was, stuck somewhere in some tourist place yesterday, so that's why I didn't, conduct this event yesterday. So that's why I rescheduled to today. So sorry for that. And so next whole year, so next 52 months, so we are conducting this event with the 52 speakers. So once again, and very welcome. And let me share my screen. Okay, 1 minute. And before that, yeah, give me 1 minute. So I hope you were able to see my screen. So let me know if you are able to see my screen. So it's a, I mean, stream. So that's why I'm unable to see here. Okay, let me change the theme. Yeah. So hope, yeah, sorry for the delay and hope you're able to see my screen. Right. Okay, so most of the agents need ability to find the relevant context. So I would like to tell you something about it. So How many of you are really able to use different types of LLM models? Something like, so I would like to tell you, so like everyone using ChatGPT, right? Copilot, Gemini models. So what is the importance of this particular LLMs, right? So we have some. I mean, like we're actually looking for some information, right? For example, app Pratap Reddy. I work somewhere, so I need something, really interesting and really want to implement in my business solution. So on the time, I need definitely LLM models. So on the time, what we actually do is, so definitely we'll reach out to the any LLM. So whether it is in ChatGPT, whether it is in Google Gemini, and whether it is in Microsoft Copilot, whatever it may be. So we must, reach out to this particular, a bots, or we can call it as LLMs, right? So every LLM is designed with some set of data. So whether it is an what we can call it as the data is up to 2022 and 2023 and 2024. So it is trained up to 2025 or 2024 year. Okay, but for example, let's say if you can ask any questions related to your enterprise. For example, I would like to know my employee data. For example, I work as a data and a senior engineer. So, for example, I would like to know my employee ID. So, on that time, what we need to do. So, I would like to tell you one more thing. So, these LLMs doesn't have your enterprise data. So, doesn't have your personal data. So, on that time, what we need to. So definitely we reach out to any I mean, like, business solutions, AI solutions. All the time definitely we use racks, we use fine tuning. So where we need to embed our enterprise data, so that so once we try that LLM, it will definitely give you the proper and better information. Okay, so it is not only the conversational bots, and it is definitely agents as well. So I'm not sure like how many of you are watched the Ignite this year. So this year, I mean, it's Microsoft announced different types of, you know, announcements, like whether, I mean, it's Fabric IQ, Work IQ, and as well as Foundry IQ. So these are all of the data. So where we need to find the relevant information, and where we need to integrate this data, I mean, this IQ into our agents or any conversational models as well. Okay, so I mean, before diverting, so we have for the presentation, most of the agents need able to find the relevant information. For example, so earlier we have the console as an default status. So now we have the Java. So Java shopper agent. So where we need to find the products. So this is one of the example. And also, so Java interior design agent. So where we'll find the image designs, and Java inventory agents. So where we find inventories, and also Java HR agents. So where we find the document. Same way, we have infinity number of business requirements for developing agents and developing, chatbots. So any LLM is really have, some set of data, but they don't have real-time information. On that time, we definitely integrate RAG. Without RAG, so the Java shop page and the Java interior design agent, Java inventory agent, and Java HR doesn't work because they don't have real-time information. On that time, we definitely integrate that, and definitely will find the relevant. So as I mentioned, so whenever we integrate RAG, so for example, I assume that, so how I can find my employee ID, because these LLM models, whether it's ChatGPT, Gemini, or Copilot, they don't have real time information. At that time, definitely we need to integrate the RAG, and then once I integrate my enterprise data, then definitely I'll find the what we can say, so my employee ID. Okay, so I would like to tell you how we can integrate in a Foundry and Copilot Studio, how we can retrieve the data out of it, how we can retrieve the relevant information out of it. Okay, and how do agent answers question? RAG means. So what is RAG? RAG, we can call it as Retrieval Augmented Generation Group. It responds from an LLM in the retrieval context. For example, you are an user, I'm an user, so we have infinite number of users. So these users, okay, I'm an user. Like I would like to ask one question. So what is the best pint for bathroom was? So this is the one of the question because this is my requirement. So this question I ask for ChatGPT or Copilot, whatever the LLM we are using. Okay, once we use once we prompt this question in any LLM, so it will try to go to the another step. So that is the search. So it will try to search the whatever the relevant info. For example, we have RAG information. Like for example, let's say VOC. Excuse me. So we have the interior paint, we have interior semi-gloss paint, and we have interior endpoints paint. So because it is search the information, because this information is already embedded, so this embedded data we can call it as RAG. Okay, for example, this search of data, whether it is a vector search, whether it is a document form, whether it is an URL form, whatever the form, whether it is an what we can call it as this Foundry IQ, whatever it may be. So it will search the questions. So once it search the question, it will try to find some relevant information. We have the interior paints, Vivo's interior paints, and interior semi-gloss paint, and interior eggshell paint. So these are the sum of the information. Once we get the information, then it will try to push this information to the larger language model. See, here in the left hand side, we have user question. In the middle, we have search. Search is the where we can find some the RAG information. So whatever the RAG information, we embed to the large language model. Once we embed to this large language model, so when the user asks question, it will retrieve the information, then it will pass it to the large language model. So then it will try to apply some generic concepts, and it will try to summarize the content, and it will try to give you the responses according to the LLM standards. Okay, so for example, if you say hi to ChatGPT, it will like hi, hey, how are you? How may I assist you? Like that, it will respond. Same way, whenever I'll ask this question, it will try to give the responses in different manner because it trained with some set of different. It trained with some set of instructions and all. Okay, this is how an agent really works whenever we need to give any prompt. Or not. Okay, so then for example, user needs agents to find all sorts of things. For example, I'm an user. I would like to know something about garden watering supplies. I need to use garden hose and at least 25 feet deep house. And we have something. So user needs to agents to find all sort of things. At the time, so today we can, I know, maybe we can discuss something about how do we supercharge the retrieval, optimize such strategies, graph-based retrieval, post-read SQL, and agent retrieval with Azure AI Search. So these are the some of the things we can discuss, and yeah, and optimal search strategies. So what are the major optimal search strategies we have? For example, so different queries need different search strategies. Okay, so we have some queries. Queries in a sense like we can call it as prompt, and in vector search, and we have the keyword search. So vectors, I mean, there is some other different use cases like vector search is different and keyword search is different. Like where better once you deep dive into the you know uh, actual retrieval things, then you definitely know something about these things. So vector search and keyword search. Okay, we have 25-foot house. It is a keyword search. Okay, so what is vector search? Like 25-foot deep house. It is a vector search. So you can definitely find it, and also keyword search also. So, and also we have some other informations like we have garden watering supplies and molecular charting. So these are some of the things in vector search and keyword search as well. So there are the different queries in different search strategies. So if you, for example, if you really query this search prompt, and it will define like whether it is a vector search, whether it is a keyword search. Okay, then hybrid search. So we have vector search, keyword search, then a hybrid search. So hybrid search, the best of both, both worlds. So whether it is and like complete search tag do better. Like for example, let's say so with hybrid search we can call it as like we have top level we have keyword search, ground level we have vector search. So the hybrid search is the best for the both of the worlds. Like for example, hybrid retrieval, like whether it is a hybrid. So we can just assume like it is an combination of keywords and as well as vectors. Then it is definitely greater than a pure vector or keywords. Okay, and hybrid plus ranking is greater than hybrid plus ranking is definitely greater than hybrid. So why it is like? Let's break down this term. Keywords and vector. Like it is a combination of fusion. So that we can call it as RRF. Okay. Then it will proceed to the ranking model. So what are these ranking models? Let's break down. Okay. So if you can understand, so documents are stored in invented index, so which can be queried efficiently. Like for example, in the left hand side, we have ID, name, and description. Then it will posit these things as a term on document list. For example, 25-foot house. It is a full text search of name plus description. It will posit to that. It is an ID, document list, and relevance. So, for example, what is the relevance of this particular prompt? For example, I would like to ask the 25-foot house all the time how much accuracy, how much relevance for this particular prompt and particular response, etc. Then definitely, so once you get the relevance information, then that relevant information will pass it to the any AI model, like whether it is a chat GPT or I mean whatever the LLM we are using. Okay. Then vector search. So vector search is mainly two things. Like one is encoded queries as in embeddings and find semantically similar documents by comparing embeddings. So query, then compute embedding vector, again query vector, search existing vector, and clay closure vector. So these are the process and step-by-step process for the vector search. And it is best for conceptually similar matches. It will try to give you the responses according. So the earlier one, so it is an exact phrase matches. So earlier one, it will try to match the relevance, but that is keyword search. But vector search is conceptually similar matches. Just think like keyword is relevance matters. Okay, how much this prompt is relevant to this particular information. But vector search is mainly search for conceptually similar matches. This concept is really matches to this vector search or not. I mean, this particular prompt or not. So whether it matches, it will pass it to that particular information. Right. Then, so we already told something. It will fusion, right? So fusion is an RRR. Okay, reciprocal rank fusion. Okay, we have garden watering supplies. This will be passed to the keyword search. This will be passed to the vector search. So we have something like in keyword search again we have rank and product. It will rank accordingly. So which one is similar to this relevance? Which one is similar to this concept? So once it is finalized, then it will pass it to the reciprocal rank filter where it will rank accordingly. So which one exactly matches? For example, so rank and product. Okay. For example, whatever the prompt is related to this particular response, for example, it will rank it. So, for example, my name is Pratap Reddy. I'll find some information related to my name is Pratap Reddy. For example, 1,000 responses, 1,000 information. On that time, it will rank accordingly. So that rank we can call it as which one suits, perfect. For this particular prompt. So then it will rank accordingly. Okay, my name is Pratap Reddy. It will be on the top level. Same way, drinking water safe house. It is in the top level. So this is RRF ramp is 0.0318. So it is maximum we need. So if we have the maximum rank number, so then it is the best for whenever we need to retrieve the information, whenever it will try to give you the best information out of it. So this RRF is very important, like while using text and vector search, much as results using RRF to rank results based on the retrieval ranks. Okay, I'll tell you simply. So I search something. I'll find some. 1 lakh information about that particular prompt. And that time it will rank accordingly. Which information suits for this particular input prompt. That is, we can call it as aura. Okay. Again, re-ranking. So again, so once it is re-ranked, once it is done, like it will gardening, so it will search and it will re-rank. So that's why. So once, for example, it will find 1 lakh responses. At that time, it will rank. So which one scores the better one? Which one is relevant information to for this particular what we can say particular information for this particular prompt, so that it will be really good. So yeah, that is the one thing. And so tip, this is something like you can find it somewhere, like so if you need and so a complete hybrid search. So these are the some of the concepts in retrieval, like retrieval augment generation. So question, so this is the question we already asked. Garden watering supplies, right? So we have the user queries that is possible to the keyword search and as well as vector search, where we have some information. We have some, prompts like the drinking water safe house, garden soil enrich, and misting sprinkle kit, and soaking houses. So these are the one of the prompts. It will posit to the information again fusion. So the fusion is RRF, that is retrieval ranking fusion. Okay, where we will find the, it will try to give you the some ranking. So for example, again it will try to pass it to the re-ranking. Okay, I'll tell you. You have one prompt. That prompt you can text it in ChatGPT. That ChatGPT is pass this prompt to the some keyword result and as well as vector result. So once it is give some ranking, again it is try to push this information to the RRF, where it will try to fusion this one. So it will try to give you some ranking, so some random ranking. So for not random ranking, it will try to give you the some exact top matches rankings. It will try to, and again this fusion ranking again it will pass it to the re-ranking. Then it will try to give you the exact responses what we are actually looking for. So that is, we can call it as re-ranking. So user queries, keyword search and vector search, then it will pass it to the fusion where we will find the RRF. Again, it will pass it to the re-ranking. Then where we'll find the exact responses what we are looking for. Then, so hybrid search is supported to many Azure databases, like where we have the vectors, like, Azure PostgreSQL and AI search and SQL and Cosmos. These are the main databases where we need to store our enterprise data, or like personal data, whatever it may be. We can call it as. So these are the some of the vector search, what are the things available, and keyword search, what are the things available, and RRF, what are the things available for these databases, and the re-ranker, so where it will generally available. So we have some private review for the Azure Cosmos DB, for MongoDB. So these are the some of the things we definitely know something about monitoring. So if you need, definitely you can take the screenshot, or you can use this recording for later as well. And I just upload. So there's a one YouTube live is also happening in YouTube as well, so where you can also replay this one. Okay, so these are some supported ways for the Azure databases. Okay, then what we can call one minute. Okay. So impact of hybrid search across query types. So we have the query type. So keyword search, vector search, and hybrid plus semantic rank. So these are the main concepts of impact of hybrid search across query types. So we have concept seeking. So these are the query types, and we have short queries and medium queries. So I'm not sure like how many of you are aware of prompt engineering. So where we can find zero shot, few shot. So these are the some of the techniques. So if you can, you definitely you must you know try with learn that concept. So once you learn that, you will find very good information as compared to the earlier. Okay, so just go through these things. But hybrid search is not always enough. Okay, so we have something. So queries requiring external language. So whenever we need to query anything, so it is definitely external knowledge. So do you have to query? So for example, let's say to carry any of the pesticide approval for use in Berkeley NCA? No. So we have the queries about relations, and we have the multiple questions in one query. So these are the some things. So that's why habit search is not always enough. So we have some other concepts in RAG, that is RAG. Okay. So agentic graph RAG with Azure Data School for PostgreSQL. Okay. Okay, we have users ask hot questions about retrieval data. So I want a cheap garden house that's retrieve highly as expensive houses. I want to headphones with the noise cancellation and good reviews on better. So these are the some of the things we definitely reach out to the Java shopkeeper agents, where we'll find the some relevant information and retrieval data information. Okay, then RAG with graph queries. Hmm? So RAG with graph queries, where use graph queries to improve results to complex scenarios by leveraging relationships. For example, one is large, I mean, if you have the question, that will pass it to the chat GPT or any LLM, so that it will pass it to the LLM, that it will graph query, and once it is done, it is again it is pass it to the, I mean, this response is again it is pass it to the large language model. This is the to and from model. If you give the prompt, it will give you the response back. Okay, and these are the one of the main concepts in RAG as well, like Apache Azure database for PostgreSQL. So one is Cypher plus SQL, hybrid queries, and fast graph processing, and as well as graph visualization and analytics. So one is data, and one is Apache AC. Then it will pass to the agent. For example, we have the data that is stored in PostgreSQL. It will retrieve the data from there, and it will try to pass it this information to the any agent. So that we can start relational and unstructured data into the query goal graph. It will analyze, it will query that it is an A, it is an graph where we find information about whatever the data we are looking for, whatever the response we are looking for, that is embedded in the PostgreSQL. Okay, then so we have different steps to build the graph with semantic operator. So if you find this one like product and feature review, product feature review. So we have the Azure extract product features review. So you can use this things whenever you need to use any SDK. So where you find very good information out of it. Okay. Step two, query the graph for complex relationship. So here we have the product relationship. So we have the product review graph where we have nice cancellations and has a feature of positive sentiment. So it doesn't have any negative or bad comments. So on the time definitely relationships is like positive, negative, and neutral. So if we have the good information, definitely. If we have bad information, it is called it as negative information. So that's why we'll get it the complex relationships and all. And yeah, and we have something. So agent retried with Azure search as well. So this is the one of the. So we have different, So user ask hard question about unstructured data. On the time, what we need to. So definitely we reach out to Azure AI search in Azure AI Studio. That is, we can, I mean, wherever it is integrated, like Azure AI Studio or Google Studio or let's say, AI toolkit in VS Code. So you can find these things. So how user hard questions about unstructured data on the time we definitely use the Azure search. So you can find the retrieval agentic retrieval with Azure search knowledge base. Okay, so here we have input conversation query planning. So for example, input is one conversation between me and my chatbot. So where we have the query planning about one is search one query and another one is a search query two. Okay, and another thing is retrieve, iterative retrieval. So that is directly treatment to the output, from output to the query plan. So where we will definitely get the information out of it. Once, for example, let's say if you have the query plan, it will pass it this information to the search query one and query two. Then the first query, it will search the information from the search indexes and one lake and SharePoint and Bing. So these are the knowledge bases. See, I mean, these are not only the knowledge bases. These are not only the four. So we have almost 20 plus knowledge sources where we need to embed our information to this AI chatbot. So for example, one such query is, this is, I mean, example one. Same way, such query is not only one or two, so it is having n number of such query. So every query, it will pass this, such prompt to the all the knowledge sources. If you find information, it will directly, pass it back via output. So much results and active log answers synthesis. So these are the output we are getting information. So once it is getting, so then it travel information to pass it to the query plan. Okay. So query planning, aging method applies the retrieval knowledge of source selection and result much. I will tell you one more thing. So I'm a user. I'm using ChatGPT. I'll ask some questions. These questions, it will be shooted to the different databases. These databases in different formats, like search index, OneLake, SharePoint, Bing, Azure for Cosmos DB, and same way we have the different knowledge sources on that time. So every question it will pass to the all the databases. It will run every time. So whenever I ask any question, once I pass this question, if you find any relevant information, it will pass it to this LLM model. This LLM model again it will summarize the context and then it will pass it to an output. So whether it is a merge result and activity log or answer synthesis, once it is done, it is revert back to the iterator retrieve. So these are the main concepts of agentic retrieval with actually such knowledge base. Okay, so here we have the minimal, low, and medium. So low latency, low model usage, and low cost. So this is the minimal one. And the medium one is high quality and increases stages and more agentic. So these are we can call it as knowledge based retrieval reasoning effort. Okay. So knowledge base with minimal effort. So we have the minimal doesn't include query planning, knowledge source selection, web source, answer synthesis, iterative retrieval. And we have the inputs in different input is in n number of such intent, and it will pass every question to this all the knowledge sources we are integrated into the chatbot or agent. And once it finds the information, it will pass it to the output. Then example of minimal effort. So if we have the activity lag in such step one and details and merge the result, whether it is it will try to give you the responses accordingly. So but re-ranking score is 2.95. But Java bathroom post PDF, it will find a re-ranking of 3 points. So whenever just assume like this re-ranking score is maximum. So on that time, we assume. So this is a very good information. This is a very good information compared to the other results. Okay, so just note it down like re-ranking score is we need whenever search like it is very very high and knowledge base with low effort. This we already discussed. Input, query planning, search queries, knowledge sources, and output. So these are the sum of the things. Okay. Then example of low effort with Bing Web Knowledge. Okay, so we have the input, we have the output. So output is in different fronts. We have the activity lag and merge result answer sources. So mainly, whenever activity lag, for example, if you can ask, these are the prompt techniques. Okay, like so if you can ask in details, like what actually you are looking for. Whenever you need to prompt, you are looking for any response for that. So you need in the activity log way, you need in the merge result, you need in the answer synthesis. So most of the chat GPTs, most of the LLM will try to give you the answer synthesis responses. It will embed everything. But if you need like activity log way others, at that time you definitely will find something relevant. If you try to prompt for your LLMs and all. Okay. Then knowledge base with medium effect. So we have the input and we have the query planning, such one, such two, and it will pass it this knowledge bases, and it will have will get the finally outputs as well. This is we already discussed like with the low effort and medium effect as well. So same way, like answer synthesis in the different. So how again we have the activity log and merge result answer synthesis in the different responses we are getting. But thing is, we have to explain how we are prompting through this any LLM or any chat any LLM. So whenever we need to looking for whenever we need to retrieve some information out of it. And so we have open source like you can find it somewhere here. And what's next? So design your agentic flows carefully. So whenever, so this is the final thing I would like to explain. So design your agentic flows carefully. Like it means, so I mean, so maybe the next step, maybe it will be a lot of time. Like maybe whenever I have time, definitely I would like to show you the demo how we can try to I embed this data and so that it will be easy for you guys to understand. How we can integrate this RAG into this Azure AI Foundry. So I mean, after this session, I'll definitely put some video links. How I think I already recorded some videos. So in my YouTube channel, how we can embed this RAG inside. Uh, any LLMs. So I would like to show you so that it will be easy for us to understand how we can integrate this RAG. So design your agent flows carefully, like evaluate your agent at each step in the process. So we have to evaluate every time. And retrieval is often a big factor for affecting output quality. Definitely. So this is one of the things. So whenever we need to design your agent flows, so we need to play carefully whenever we need to retrieve. And the data preparation. So very important. It affects all the retrieves and set up automated evaluation so that you can significantly measure the different search approaches, data preparation techniques, and models. So we have question, search, language model, that is large language model, and it will pass it to the. So whenever we need to create any agentic flows, we need to, must and should we need to like some innovative things are what we can call it as. We need to be careful with this designing solutions. I mean, we must evaluate your agent at each step, and retrieval and data preparation, and set up automated evaluation. So once it will run, it will try to give you the proper response. So agentic flows, maybe you'll find it somewhere in Copilot Studio. So where we have the agentic flows. So it is similar kind of for automate solution. So where we need to automate, flows for the agents and also it will try to give you the responses back. Okay. So thank you so much. And if you want to download the slides, so definitely it will. You can scan this QR and you'll find it. Okay. Okay. Thank you. And so we will definitely, so we'll definitely, try to catch up in the next week. So we have another speaker. So I'll host that speaker the next week. So I'm the host of this series. Like after this session also, like if you feel free to reach out to me if you're like, really looking for any information related to the agentic world or a chatbot model. So how we can embed the chat G. This RAG solutions to this all the LLMs and all. But one thing I would like to tell you. So every chat GPT, every LLM have some trained with some set of data. But thing is, we didn't what we can say um, but that particular large language model doesn't have the enterprise information, personal data on the time. Definitely, we need to integrate this information, whether it is in different formats of data, whether it is whatever the format of data, whether it will be embedded in databases, whether it is a PDF, Excel sheet, and whatever it may be. So we need to we are giving this access to this chat GPT. It will retrieve from this databases so that it will be easy to give you the responses back. Okay, so these are the some of the things I would like to say something about RAG. If you have more, if you need more information, if you need anything, so definitely. So anything related to AI Foundry. So innovation tech community is the right place. Where you'll find a very good, you know, what we can say we'll find definitely so very good information out of it. So we have the very good speakers from throughout the world. So stay tuned to the innovation tech community for more updates. So this 2026 year is boon for innovation tech community. And finally, wishing you a very 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 happy New Year and a happy Pongal and happy Sankranti. So thank you so much and see you next year that we can call it as 2026. Okay, so this is Pratap Reddy signing off from Innovation Tech Community. So thank you so much.